Math is patterns. It's just a way for us to describe the patterns that happen around us. Fortunately for us, a sequence is a pattern. An arithmetic sequence is a pattern. There you go. A sequence is just a list of numbers in a specific order, and the list is arithmetic if you had the same thing every time to get to the next number. Okay? So the pattern for an arithmetic sequence is you add the same number every time. That number can be positive or negative, so it's the same thing as subtracting the same thing every time. You know, addition to subtraction are basically the same thing. That thing is called the common difference. The common difference. Yeah. Okay. The formula in red is the same formula that's on your formula sheet. That's the one we're going to use the most. The other version, if you are clever and know how to manipulate formulas, you could use that version as well, especially if they don't tell you what the first term is. So the second formula on the sheet, where it says an is equal to an minus 1, that one, that's if you don't know what the first number is, but you know other numbers on the list. Okay? So again, with these formulas, you should only be missing one thing. That's it. You only miss one thing. Find that thing, and then find the rest of the list. That's the goal for today. Yeah. All right. That's it. Let's do it. Here we go. What's the pain? +3 every time. Right? So you're adding 3 every time. That's what makes this arithmetic. You just add the same number over and over again. So after 8 is. Woo! Next pattern. Take away 5. So your common difference is actually -5. Subtracting 5 is the same thing as adding -5. Okay. Alright, so as you can see, the pattern continues a couple times. It happens that way. So after 16, 11, 2. Come on! There we go. Woo! Not 2. A higher. Right? Not 2. Okay, I have 3 over 2. The next one! Oh, Shabria, you're so smart. Okay, add another half, you get 2. Then, 5 over 2. 3. Yeah. That would be 9. Right? Yes. I mean, you could use a calculator and then just convert it. Whichever. Alright. Alright, this is leading us up to this formula. Here we go. Find the missing number. Right? Assuming this is arithmetic, we had to add the same thing every time. Right? So, to get to 17, we started at 5 and added 2 D's. Right? Start at 5 and add 2 D's, you get 17. True? It's not for D. So 12 is equal to 2D, so D has to be 6. So in other words, we're adding 6 every time. Let's check. 5 plus 6, 11 plus 6, 17. Okay. If you take a look at that formula, that is the same formula as you had in red. 17 is AN. It's the end number. 5 is A1. Where's the 2 from? Well, how many numbers are there? 3. It's 3 minus 1. Take a look at that formula. Yeah. Let me go back. This formula. It's the number of numbers, and it's the number of numbers. Thank you. Yes. All right. So, go. AN is the end number. It's the last number usually, or it's some number on the list. Yeah? And N is the number of numbers. Hey, I like that here. That's good. Okay. Okay. So again, that just illustrates why that thing works. Because you take the number of numbers, take away 1, multiply by b, and then you're adding to the first number. Go. Here we go. Yes. 3 minus 1. There's 3 spaces. That's right. All right. 6 arithmetic means. An arithmetic mean just means the numbers between. All right. So we start at 12. There are 6 numbers between 12 and 47. 1, 2, 3, 4, 5, 6. There's 47. Right? Again, just to prove that formula to you, we add D here. Okay, how many D's do we add? 2, 3, 4, 5, 6, 7. How many numbers in this list? 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 1 is 7. That's why it's n minus 1 in that formula. It's a number of numbers. Yeah, 17. All right, so to get to 47, right? Start at 12 plus 7, 8. Yay. Okay. 35, is that right? Yes? So D is. So in other words, we're adding 5 every time. Okay. Yeah. So 17, 7, 2, 7, 2, sure enough, plus 5, 47. Yay! I love this. Alright, wait till I get to multiplication. Alright. Okay, here we go. Oh, yes. Okay, there's 2 parts to this problem. Part 1, the explicit formula. The explicit formula means the general formula. Okay? So your general formula is just like, it's AN because it helps you solve for any number. So in this explicit formula, remember the formula goes AN is equal to A1 plus n minus 1D, right? That's the formula. Plug everything in except for AN because that'll help you find any number in this formula. So A1 is 3 plus n minus 1. We don't know. We don't know. But we know that D is 5. Oh, we will. But to find the explicit formula, you don't plug in AN or N. We're basically finding a general formula. Okay? When you distribute that 5, you're going to get 3 plus 5n minus 5. That simplifies to 2. Yeah. So AN is equal to negative 2 plus 5n. 5n minus 2. Whichever. This is called the explicit formula. Okay? So that'll help you find like the 123rd number. Basically, if you want to find a crazy number, like 100, like your numbers after this, plug in 123. And then solve, and that's 123. Right? But if it's only the first 5 numbers, that's silly. It's not going to work that hard. 1, 2, 3, 4, 5. First number is 3, then 8, then 13, then 18, then 23. Okay? I mean, the first number is 3 and you add 5. So here's how we check our explicit formula. Right? The first number is 3, and you add 5 every time. So there's the first 5 numbers. So let me prove to you that that explicit formula actually works. Pick a number 1 through 5. 4. I like it. Right. So this is A4. Right? Okay. So A4 would have to be negative 2 plus 5 times 4. True? 5 times 4 is 20. So negative 2 plus 20 is 18. So that formula solves for any number in the list. It's the 4th number. n means the number of numbers, so it's the fourth number. Yeah, the position of that number. How do you know that we're adding 5 every time? Good on you, mate. Right? So yeah, you look out for what you're looking. You usually have AN, A1, N, and D. You gotta know which one. You do not for the first 5 terms? Heavens no. No, but I was just proving to you that that formula works. So like on the SOL, they're gonna ask for some crazy number like 297. Like just plug in 297 for N once you get the explicit formula. Hey, yeah. All right, here we go. Let's start again. Hey Caitlin, what are we at here? It's the birthday, 210. Woohoo! Here we go. The explicit formula. First part. AN is equal to B1 is yep. Plus the N minus 4 times negative 2 plus 10 N minus 10. Makes it negative 12 plus 10 N or N minus 1. 10 N minus 1. There's your explicit. Okay? So, again, for the first 5 terms, just make a list. 1, 2, 3, 4, 5. Where do we start at? Negative 2. Add 10. 8. Add 10. And 38. Do you want me to prove that explicit formula works? Oh, okay. You want to see it? No. Pick a number 1 through 5. 2. I like it. So this is A2, right? A2 is going to be negative 12 plus 10 times 2. So negative 12 plus 20 is any number on the limit. Yeah, it's like not a big number. He does card tricks where? In the gym? Well, that's fascinating. I love me some good magic. Good magic. Alright, here we go. Backside. Good. Alright. I can do it. Here we go. What is 12? What's the 12th number? Yeah, it would be nice. Now here's the deal. We know what? We know the first number. What's A1? Negative 17. What else do you know? What's the common difference? Yep. Right? So we know our common difference. N. What's N? 12. We're looking for the 12th number. So N has to be 12. Like I said, don't really get this here. Okay? Alright, so the 12th number is going to be start at 17 plus N minus 1, so 12 minus 1 times 4. Right? So negative 17 plus 11 times 4. That's right. This is so easy now. This is fun. 12 numbers give me 27. Right? That's it. I know. This is so good. Remember how like last time you had to come up with a formula? I give it to you. You just have to figure out if it's arithmetic. Alright, here we go. Is we're adding the same thing every time. Right? Yeah, if you're adding the same thing every time. Multiplying the same thing every time, that's geometric. Which we'll get to on Wednesday. Adrian, question or you're just finishing? It disappeared. Let's do it again. Same question, different numbers. Here we go. 2 Tell me what you know, tell me what you know, tell me what you know. A1. Yes. What else? T is 3. Is it negative 3? You're right. You're right. D is negative 3. That's very good. And it's put it all together. Pump that out with your calculator. Just tell me what it is. Tell me what it is. Ah! Yes! That's fast. That's what. Yay? Over. Alright. If I told you what the last number is, can you tell me how many numbers? Yeah, you can. It's manipulating the same formula and just finding that one missing thing. You can do it. You can do it. Alright. Okay. 170 is the term of negative 4, 2, 8. Let it go. Get out. T is 6. Woo! What's the last number? And it's what? Say. So what's the number? Because that's the only number you care about on the list. Yeah. Right? So AN is the last number, isn't it? It could keep going, you're right. But for our purposes, it's going to be the last number because that's where we're going to stop counting. Yeah? Okay. Alright, so we know AN is 170. So 170 is negative 4 plus times 6. Right? Okay. So negative 4 plus 6 minus 6 is negative 10 plus 6 minus 6. Simplify the right side. Now 4. Add 10. So 180 is equal to 6n. That's 30. So 170 is the 30th number. Okay. It's the same formula. Just manipulate. Hello. Look at you. So you're just manipulating that formula. That's what it is. Yeah, because by adding one, you're doing the opposite step. True. Okay. Okay, if it's working, go do it. Yeah? Alright. Here we go. Almost there. 2 more. What do you know? What do you know? G7. I like it. I like it a lot. So, yeah. Woo! All of that math. All that math. Plus 7 and minus 7 makes it negative 9 plus 7 and 124. Yeah? And dot, dot, dot. And it's equal to 19. Okay? Yeah. Did plug it at the 9 divided by 7. Right? So that would be the 19. Okay, did you do the last one? No. 18. Two. Oh, yeah, what did you guys? Yes. Yeah. Go ahead, Ian. It's good. Yeah. Yeah. Right. In this one, what does he know? Everything except for D. Question, what's N? 11. So the 10 is actually 11 minus 1. Right? Genius. Very good. Oh, 11 is your end, so 11 minus 1. No, I'm really glad you said that. 11 minus 1 is where that 10 came from. Yay. Alright, do you remember your number that was on your paper?
Yeah.
You only have to do half of it, so odds do odds, evens do evens. When you're done, turn it in, bingo. Oh, I got you over here. Oh, what did you do? How did you do it? How did you do it? You have to show me how you get it. Uh-oh. And they all lived happily ever after.